The building here on the APL campus where the science team is working. The science team assembled 5:45 this morning for a chance to see that best image of Pluto and to react to it and to have a little bit of a scientific discussion. And I think we're going to give you a peek into it if we can cue it up.
In 2015, the space community was filled with immense excitement. This excitement stemmed from the fact that prior to that year, the best image we had of the Pluto system looked like this. Even the powerful Hubble Space Telescope had attempted to observe Pluto, but due to its small size and considerable distance, it could only capture a few indistinct blobs of color variation. However, everything changed in 2015. After a 9-year journey through space, the New Horizons space probe conducted a close pass by the dwarf planet, providing us with an unprecedented level of detail and clarity in our view of Pluto and its moons. So, what did the New Horizons probe see and uncover during its flyby of the Pluto system, and what has it been up to since the flyby? In this episode, we'll delve into the hidden side of Pluto. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space and beyond, consider subscribing. Launched in January 2006 from Cape Canaveral Air Force Station, New Horizons embarked on its primary mission of capturing images and gathering data about Pluto and its moons, including Charon, Styx, Nix, Kerberos, and Hydra, some of which had not yet been discovered. On July 14, 2015, after 9 years of exploration, New Horizons made its closest approach to Pluto, unveiling an astonishing view of its surface, revealing ice mountains, nitrogen glaciers, cryovolcanoes, and canyons that surpassed even our wildest expectations. However, due to the vast distances involved, data transmission was restricted to a mere 1 or 2 kilobytes per second, resulting in a 15-month wait for the complete dataset to be downlinked, creating immense anticipation with each new image release by NASA. As you gaze upon these images today, your sense of wonder remains undiminished, as there is a wealth of information waiting to be deciphered, akin to solving a complex puzzle. Let's begin by examining a distinctive feature known as the brass knuckles, located near Pluto's equator. This feature consists of 6 lowland regions, referred to as maculae, each with an average width of approximately 480 kilometers, roughly the size of Iceland. A closer inspection reveals that these maculae are intricately connected by a network of canyons named Kroon, Alla, Balrog, Vukubkame, Hunkame, and Mengpo, with each name drawing inspiration from various netherworld spirits from world mythology. Notably, Balrog Macula is an homage to the wizard-battling demon from Middle-earth, a treat for Lord of the Rings enthusiasts. The dark hue of the brass knuckles is believed to result from a tar-like substance composed of tholins, hydrocarbons formed from the interaction of methane and nitrogen with cosmic rays. Tholins are prevalent throughout Pluto, including in the neighboring whale-shaped region known as Cthulhu Macula. The reason the brass knuckles appear distinct is due to the presence of towering uplands covered in ice that divide each macula. These uplands reach several kilometers in height and likely consist of frozen nitrogen, methane, and carbon monoxide atop a bedrock of water ice. On Pluto, water ice can form substantial mountains due to its low gravity, whereas nitrogen ice is softer, leading it to fill the lowlands. One can only imagine the breathtaking view that these colossal ice mountains present when observed from the perspective of the canyons. Nitrogen dominates Pluto's surface, constituting a staggering 98% of its composition. Moreover, nitrogen ice plays a significant role in shaping one of Pluto's most recognizable features, Tombor Regio, aptly named after Clyde Tombaugh, Pluto's discoverer. This heart-shaped region is divided into 2 distinct lobes, with the western one forming a smooth basin covered by a vast expanse of nitrogen ice known as Sputnik Planitia, while the eastern lobe displays a much rougher terrain. When examining this image closely, one can discern intricate details. Moving from west to east, the contrast becomes palpable. The eastern lobe exhibits a pitted appearance, reminiscent of the skin of an orange. Scientists theorize that Pluto's winds transport nitrogen from Sputnik Planitia into the atmosphere, depositing it onto the eastern uplands. This process contributes to their high albedo, which measures the surface's reflectivity, causing the uplands to gleam with a bright icy sheen. Some of the transported nitrogen likely flows back into the lowlands through glacial movements, fostering an intriguing interplay between the western and eastern sections of the heart-shaped region. This arrangement, while unusual, reminds us that every heart harbors its enigmatic secrets. On the western side of Sputnik Planitia lies a towering mountain range named Al-Idrisi Montes. Here, winds carry minuscule particles of methane ice towards the mountains, akin to grains of sand returning to the surface. This phenomenon is remarkable because Pluto possesses an exceedingly thin atmosphere, which was not expected to support such transportation. Most likely, sublimating nitrogen ice lifts these methane particles into the atmosphere, where they are deposited closer to the mountains. These methane deposits form a sprawling field of transverse dunes spanning 2,000 square kilometers, bearing a resemblance to dunes found in Earth's Taklamakan Desert or Death Valley in California. Unlike terrestrial deserts, these dunes emerge in frigid temperatures as low as -230 degrees Celsius. The minuscule methane grains comprising these dunes are considerably lighter than sand, and due to Pluto's weak gravity, would likely feel akin to fine dust slipping through one's fingers. Nevertheless, considering the extreme cold of -230 degrees Celsius, attempting to touch them would not be advisable. The dunes are not the sole point of interest in this region of Sputnik Planitia. On the western side of the mountains, there exists a deep trench, distinguishable as a dark blue band on the colorized elevation map. Based on our measurements, the peaks adjacent to this trench range in height from 200 meters to 1 kilometer, while the more distant peaks soar to impressive heights of up to 3 kilometers, almost rivaling the stature of the Rocky Mountains. What makes this noteworthy is the potential connection to the intriguing phenomenon beneath Pluto's surface. Recently, a fascinating revelation about Pluto has emerged: the possibility of a vast subsurface ocean, a characteristic it shares with several other celestial bodies in our solar system, such as Ganymede, Europa, and Enceladus. This is especially astonishing when you consider Pluto's considerable distance from the Sun. To maintain a subsurface ocean, Pluto must generate significant heat, possibly through nuclear decay in its core, despite being smaller than our own Moon. Given its modest core size, expectations for substantial heat generation were minimal, making the evidence for a subsurface ocean a surprising revelation. Now, you might be wondering about the relevance of this discovery to the mountains we previously discussed. Well, a 2019 study presented at the Lunar and Planetary Science Conference proposes that the movement of the Al-Idrisi Mountains to the east could have been a result of solid-state convection. This process may have given rise to both the deep trench on the mountain's eastern side and the elevational uplift observed from west to east. If this hypothesis holds true, the dynamic surface processes on Pluto would lend support to the notion of a liquid water layer beneath its icy crust. Additional evidence comes in the form of cryovolcanoes, with Right Mons being one such potential cryovolcano. Here, in the highest resolution color view assembled by the New Horizons team, you can witness Right Mons, a massive structure predominantly composed of water ice, towering 4 kilometers tall and featuring a prominent depression in its center. Its relative lack of impact craters in the surrounding area suggests recent activity. Another potential cryovolcano, Picard Mons, located to the southwest, stands even taller at 7 kilometers, although images captured by New Horizons were less clear due to darkness. Nevertheless, it is visible in the colorized topographic map displaying a substantial depression at its center. These depressions bear a resemblance to Earth's calderas, but are proportionally larger relative to the size of the volcanoes. Upon close examination, concentric rings surrounding the depressions hint at a series of eruptions, followed by the withdrawal of magma and the subsequent collapse of the vents. To make it simpler, we're not 100% sure these are cryovolcanoes on Pluto, but there's a lot of evidence suggesting they might be. New Horizons found some amazing things on Pluto, and because we found signs of a possible ocean under Pluto's surface, scientists will study it more. We wonder what else we might discover. Could there be life in Pluto's ocean one day? We might even send a spacecraft to explore another dwarf planet in the Kuiper Belt, like Eris, but it would take more than 20 years just to get there. So, we should appreciate the pictures New Horizons took.